Good morning, everybody. Hopefully you had an exciting English class this morning. It's good to see everybody in chat. If you don't mind throwing in a couple green check marks, and while you're doing that, I'll just kind of give a quick rundown on where we are, where we're going. We're kind of coming close to the end of the unit here, so we have a unit test coming up. And some of you guys have started to work through that review. And if you haven't started to go through the learning guide of the review yet, then it would be a really good time to start that in the next few days. Just behind me, I have the course set up. Where we are, we did lesson 5 last day. So we went through that. We're going to go through lesson 6 today. And you'll see that that's the end of the unit. So we're going to go through lesson 6. Same sort of layout. There's one little quiz that I'd really like you guys to do before Thursday. Then we have the learning guide submission. So kind of like we did for the review at the beginning, the submission for the learning guide kind of looks like, there's a little video here that kind of explains things. But basically all you need to do is have one file. The very bottom of the page, you're going to have an add submission button down here. You can see it. So you're going to click on that. You're going to find the file with all of your work, and you're going to upload it. And this is the rubric that we're going to use to mark that. So basically, there's some marks for completion, and there's some marks for showing your work. And it's difficult for me to go through every one of those questions and make sure you've done them all properly. If you imagine there's whatever 30 questions times 30 students, and if I took a minute to do each question, it would take forever. So basically what I'm going to do is just going to pick a couple of the questions and going to just have a quick look at them, make sure you're getting the right solutions. And if you do ever get something wrong, I'll just send you a little message in Moodle and say, hey, these few are wrong, so you might want to go back and look at them. As I was kind of explaining last day, we need to submit that unit guide before you can write the test. So I want to make sure you guys know kind of the material, you know what's going on before I send you off into that test. I sent an email out to everybody's families this morning, or your parents, I suppose, and just explained a little bit about the test. So I'll just explain it to you guys as well. When you go in to write the test, I'll just click on it so you can get a bit of an idea. Maybe you've seen it open. Mine says continue the last attempt, but yours will say enter quiz password. So once you've submitted your learning guide, I've gone through it, maybe given you a few pointers on what needs to be done, I'll fire off an email to your parents with the quiz password, and then you can have them enter that for you. Then the quiz will open up, and it's 20 questions. It's basically we have a really big test bank, and the computer, Moodle itself, actually just picks random questions from specific sections. So it'll be a good mix of everything we've done so far. You guys should have a good grasp on most of this stuff. I know the last stuff that we did, the circle stuff, or spheres probably wasn't too hard, but before that, the triangles and pyramids and things like that was maybe a bit trickier. So there you go. That's the test. Somebody asked, Abby asked, do you want us to do the review for Friday? And I don't, I would love it if you did, but I'm not going to say it must be done on Friday. Some of you guys may be going away for the weekend and won't have time to do these things. So I've put a date on that test. I put Tuesday next week. So if you can get the learning guide in on Friday, I'll have a chance to look at it, and I can send the password to your parents, guardians over the weekend, and then you can have some time to do it then if you're around. If not, I'll have a look at your learning guide on Tuesday, because Monday's a holiday, and then you'll have a chance to write that test on Tuesday. So that would kind of be the last day to write the test, would be next Tuesday. Just want to keep everybody together. We're going to send out some interns. I believe we're sending them out today or tomorrow. And we're going to make sure everyone's kind of in the right spot, just so everybody's aware and your parents are aware where you're at in your progress. So in terms of the quizzes, hopefully you can get that number 4 quiz done for tomorrow, but everything before that should be complete now. So the first 3 quizzes should be done with this unit, and the review we did for the introduction. So those are really the only 4 things we've done. Haven't done a lot. By next week, though, we should have all of these quizzes done and then that first test. So a few questions here. How long should the test take? It's 20 questions, so I would imagine it'd maybe take around an hour. Everybody's going to be different. I'm not going to say it should take this long. And one thing I want to apologize for is the first few quizzes I shut off that timer, and then I forgot to do it for the next few. So I went in and shut off the timers for all the quizzes, and the test won't have a timer on it either. So just completely forgot about the timer. So there will be no timer on it. It takes as long as it takes. You shouldn't have anything out while you're writing the test. It should be just closed book. Just have some paper, a pen or a pencil, and just go through it. If it takes you half an hour, then that's fine. If it takes you an hour and a half, that's fine. The only one thing that I'm kind of a bit concerned about is that the final exam that we write, the provincial exam, you're given 3 hours. So if you're taking a long time to do these unit tests, then that might indicate that you don't have a strong understanding of the material. So because that final exam kind of hangs over our heads throughout this course, you definitely need to be conscious of how long you're taking on these things, because you don't have an infinite amount of time on that final. Can we have our formula sheets too? Yes, you can. You can have those out, and I didn't include that in my email to your parents, so I'll have to fire off another email. Definitely formula sheets, some blank paper, pen or pencil, and your scientific calculator. Those will be all the things you'll need. I know it'll be a little bit kind of different because this will be the first one you guys have done, but I'll tell you this. The quizzes that you've been doing and the test, they all draw from the same test bank. So there's a chance that if you do each of those quizzes twice, some of the questions you've seen on the quizzes might even show up on the test, because it's just pulling from the same bank. It's a really, really big bank, but it's the same bank. So if you've done each of the quizzes a few times, you've mastered those and done a pretty good job on those, you should be doing pretty good on the test. So I don't really have any concerns. The one thing that's a little bit different about the unit tests as opposed to the quizzes is there's only one attempt. So the idea is you go through all the quizzes, I make sure that's going kind of well for you guys, you give me that learning guide, I make sure that's going well, and then I set you free on the test. If at any point along there, like your learning guide's not really up to par or your quiz marks aren't amazing, then we can meet and go through some of the stuff and make sure you're ready to write the test. I don't just want you to write the test for the sake of writing the test and be concerned about it. So that's kind of where we're at. Does anybody have any other questions about the test or quizzes or where we're at, where we're going? I'm going to go through the lesson 6 today. I'll go through some of the older material or any questions you had from yesterday's assignment. And I'll probably start the new unit tomorrow, even though you guys haven't finished this test yet. If you guys have a ton of questions about the stuff, then some good questions coming. If you have a ton of questions, I can go through them next day. How many pages is the learning guide, and is there multiple choice in the test? Yeah, the test is the same sort of layout as the quizzes. Some of the questions are multiple choice. Some of the questions are just entering the numbers, the actual digits. There's like caliper questions in there. I think the test bank has one micrometer question in there. So just spend a little bit of time looking at how that micrometer works. If you have some questions about it, I can go through it next day maybe. Jade has a question about the learning guide. Sure, throw that into chat. If you have any questions about the work we did from last day, the sphere stuff, I'd be happy to go through those now. What I'm going to do is I'm going to go through lesson 6, And then it's only 3 questions long, I think, 2 or 3. And then once I've done that, if there's some time at the end, I'll go through some questions from lesson 3 and 4, and even from the learning guide. So Jade, if you want to throw your question into chat, I'll just come back to it at the end. So first of all, how long does the learning guide take, Taylor? I don't know. Have you guys, some of you guys have finished the learning guide. You guys throw in questions? Perfect. The learning guide it's long. It should take maybe a couple hours to go through. There's a bunch of questions from all the units, but you can go back and look at your notes and things like that. So, but don't just think you're going to sit down in like 30 minutes and complete it. There's lots of stuff in it because it's everything we've covered, but nothing new, nothing different. Okay, you haven't started, Taylor? It's all good. If you can get it down, you said you're going to get it printed off today, that'd be good. And then you can spend the whole weekend working on it if you want, and then write that test on Tuesday next week. So not a concern. I gave you guys this whole weekend to get that test done because I knew some people are going away and you have this 4-day weekend, which would be a great opportunity if you're around. And some of you maybe have submitted it, Ava. I think you submitted it. So if you submitted that, I'll get to it today, and I'll send your folks the quiz password so you can go in and write the test. What about the interim? Interim reports just is me going in and looking at what you've completed. I send a mark. All of your marks will be together. So you have a planning mark, ADC mark, English mark, and a math mark. And those are all going to go on one page, and then any assignments you're missing will show up on there. So just so you know where you're at, where your folks will know where you're at, everybody's kind of on the same page. So there's a lot of questions, a lot of people typing, which is great. Abby has some questions about practice 5, 1, CI, and CII, so I can get to those. Jade had a question about the imperial conversions, number 2, leave us fractions if needed. I'm not familiar with that. I'd have to go look at it. But I'm just assuming that if your calculation is involving a fraction, you end with a fraction, don't just divide the fraction, leave it in fraction form. I would have to have a look at the solutions to figure out exactly what it's kind of hoping for in terms of that. So maybe just look at the answer and see if it's in a fraction form or a decimal form, but I have a feeling it's just asking you, if you end up with a fraction, just simplify it and just leave it like that. Shayna asks about, we don't have the unit review handed in by today or tomorrow. That's fine. Basically, what's going to go on the interim will be the first 4 things we've done. So we did the review from the very beginning, and then you should have 3 quizzes done by today. So quiz 1, 2, and 3. Tomorrow you should have quiz number 4 done, and then get that test done over the weekend. So hopefully that answers some questions. If you have any more as I'm going through, just fire away. Don't be afraid. I know you guys aren't, but there you go. So there's questions about practice on this. So I'm just going to have a quick look back. Number 1, CI and CII. So hopefully we can get those 2 guys done. And then I'll go through the lesson 6 real quick. So a silo for storing grain, the shape of a hemisphere placed on top of a cylinder. The height of the silo is 15 meters and the circumference is 22 pi meters. Maybe this is where we're getting kind of caught up, this 22 pi. What volume of grain is stored inside the silo if it's 75% full? All right. This 22 pi is exactly what you'd think it is. If you took 22 and multiplied it by pi, if we just pretend pi is 3 for a second, this 22 times pi is going to give us, 66. It's going to be bigger than 66, but just a decimal that goes on. What we're doing is just leaving it in sort of exact form. So instead of writing it as 22 times pi, because pi is this decimal that kind of goes on forever, it's an irrational number, we can have the exact number. So 22 times pi is exact, whereas 66 point something 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 is going to give us an approximation of what that is. So that's kind of where the 22 pi is coming from. And if you end up with pi's in your answers, you don't actually need to do the multiplication. You can just leave it as a number multiplied by pi. And that might happen here. So is learning guide worksheets from the unit? Alex is asking about the learning guide. Yeah, it's just all the sort of problems we've done thus far, just kind of into one guide. So kind of like a review, I'm calling it, I guess. So yeah, it's just all the stuff we've done from the unit. So at the end of this lesson, or sorry, the lesson 6 that I'm about to do, you should be able to answer all of those questions from the learning guide. Okay, so basically it's a cylinder with a hemisphere on top. So if we can imagine a cylinder looking like this, there we go. The height of the silo is 15 meters. And the circumference is, if you recall, the circumference of a circle is the distance around the outside. So that blue line would be the circumference. And it's equal to 22 times pi. What is the volume of it if it is 75% full? That's a few steps to this question. So I'm not sure the hemisphere on top is important, because if you can imagine this being 100%, if it's 75%, which would be about here, we're not even going to worry about any of the stuff above this. So we're not even going to fill up the hemisphere on the top. So we don't even need to worry about that hemisphere. So I'm just going to deal with the cylinder. Now this is more a question to, that's dealing with like problems like we're going to look at instead of a sphere question, but this just kind of showed up here. So one thing that might be tricking us up a bit is the circumference of a circle. Now, if you get to something like this on a test or your final exam, and you're like, oh my goodness, I've forgotten what circumference means, the best place to look is your formula sheet. I bring mine everywhere I go. And there's actually, the circumference of a circle is listed on here. So right off of our formula sheet, it says circumference is equal to pi times the diameter, or circumference is equal to 2 times pi times r. So those both deal with circumference. I'm trying to find the volume of a cylinder. And again, I'm going to look to my formula sheet, volume of a cylinder. That is the area of the base times the height. And the area of the base, in this case, is going to be a circle, which is pi r squared. And then we're going to multiply that by the height. Once we've figured out the volume of the entire cylinder, then we can figure out what 75% of it is. Now, I don't have the radius, but I do have the circumference. So I'm going to use this circumference over here to figure out what the radius is. So I'm going to have 22 pi is my circumference times 2 pi is equal to the radius. And I'm going to divide both sides by 2 pi. Now, I have pi on the top and pi on the bottom. And if I imagine dividing 3.14 by 3.14, I'm going to end up with just 1. So the pi's cancel. I'm going to have 22 divided by 2, which is going to give me 11. And this 2 pi cancels and this 2 pi cancels. So I just end up with 11 is equal to the radius. So the radius of the silo is 11 meters. Now I can plug that into my r and then multiply it by the height of the silo. So I have pi times 11 squared, and then I'm going to multiply that all by the height, which is 15. 11 squared is 121. Multiply that by pi. I have a feeling the answer is probably an exact value, so I'm just going to leave the pi out front here. So all I'm going to do is go 121 times 15. And I get 1,815 times pi is my volume in meters cubed. Now, it's asking for 75%. It's only 75% full. So that would be 100%, the whole thing, but I'm only interested in 75%. So I'm going to take that volume and I'm just going to multiply it by 75%, which as a decimal is 0.75. So 1,815 times 0.75 gives me 1,361. 0.25, I'll just leave it as a whole number, times pi. Or I can just do the multiplication. I can multiply it by pi, and it's going to give me 4,276.49 meters cubed. So there's my answer in terms of pi, and there's 1,361 times pi, which is 4,276. So that was that first one. The second one asked, the farmer needs to paint the outside of the silo, protect it every 2 years. How much paint would be required? There would be no bottom to paint the silo. So 6,576. Have a quick look. Meters cubed. 6,000. Do I keep on getting these questions wrong for a particular reason? I figured out the one I got wrong last day, which is silly of me. Pi r squared times the h, 15 meters, r. Can anyone see where your solution differs from my solution? 8,400 times 7.5. 7.5 isn't 75%, so 0.75. 1511 squared. 1815. Just give me a second here to figure. 5,700. Calculated volume, both the hemisphere and the cylinder. That could be it. I suppose that would make sense because if it's 75% full, it's also talking about the hemisphere on the top as part of that 75. So maybe I need to add that on. So I'm just going to take a step back here, lose this. Let's figure out what that hemisphere is on the top, because that'll only take a second. So the volume of the hemisphere, I'll just go HS. A sphere is 4/3 pi r cubed. And then I'm going to divide it in half or multiply it by 0.5. So 4/3 pi, the radius I know as 11 cubed times 0.5. Let's see what that gives us. 11 cubed times pi times 0.5 times 4 divided by 3. So the hemisphere at the top is 2,787.6 meters cubed. I'll take that 1815 times by pi. And then I'm going to add that 2,787.6. So I get a total volume when I add this guy to this guy. I get a total volume of 8,489. And then I'm going to multiply that by 0.75. And I get the 6,367. So I did forget the hemisphere, and it did make a difference. And you guys pointed that out. Yeah, and I guess immediately that's something I overlooked. But we got to the right spot, which is a good thing. So we definitely would need the hemisphere because it's talking about the percentage of both the cylinder and the hemisphere on top. So that would make sense. So that's that. The second part of the question asks about the surface area. So I don't know if I'll have enough room to do it, but I'll start way over on the left here. Surface area, again, we have half a sphere. So 4 pi r squared is a full sphere. If we just wanted half of that, we're going to divide by 2 because we have a hemisphere. So we get 4 divided by 2 is, forgot my r in here, 4 pi r squared. So 2 pi r squared is surface area of hemisphere. And then I have my cylinder. And I guess this is a little bit tricky, the cylinder. The cylinder only has the sides, essentially. There's no top to the cylinder because if you think about the silo up above here, it's a hemisphere on the top. So I don't have the top of my cylinder. And the bottom of the cylinder I don't have to paint because it's on the ground. So what I'm going to have to do is just take the surface area of my cylinder to be the area of the sides, so 2 pi RH. And yeah, that's called the lateral area, you're right, Abby. So we don't need the top of the cylinder, we don't need the bottom because we're not painting those. So what we're going to do is we're going to add these two things together. I'll call it surface area total, and I'll do it all in one big step. So 2 pi r squared is going to be the hemisphere, and 2 pi RH is going to be the lateral area, or the outside of it. And in this case, the radius is 11. So 2 pi times 11 squared, 2 pi times 11. And the height of this was 15 meters. So I'm going to have to plug that in to my calculator. 2 times pi times 121. I'd probably do this as 2 steps. So I'm going to get the 760, keep a couple decimal places, 26. And then I'm going to add to that 2 times pi times 11 times 15. And I get 1,036.73. I'll add them together and end up with 1,796.98, or 1,796, or we'll just go 97 to the nearest meter. and it's a surface area, so our answer should be in meters. In meters squared. And if the solution at the end is just times pi, then just do the multiplication times pi squared, or pi. There we go. How are we feeling about that? Getting there? I want to go through lesson 6, and then I can go through some of the older questions from the last few days that I didn't have a chance to go through yet. So lesson 6 is on solving problems involving objects, which is kind of funny that they put this lesson at the end, because all along we've been doing these types of problems, and now there's just a whole sort of unit lesson on it, which is kind of silly, but that's just the way it's broken down. So this is kind of everything we've been doing all put into sort of one thing. What was the answer from the last one? 5 practice. I got 1,797 meters squared. Taylor, you're trying to tell me I did it wrong again? 572 times pi. Let's see what that is. So if we take 572 times pi, or 3.14, you end up with the same thing. So if I had just left pi in here, I would have gotten the same answer, the 572 times the pi. So they're the same thing. 572 pi meters squared, or 1,797 meters squared. Just multiplying that pi through. If they ask for an exact value, throw it in terms of pi. If they ask for a decimal, you can leave it as 1,797. Well, the first part, I missed one of the steps. Do you want me to just scroll up a little bit, Shayna? I'll leave that up for a second. So lesson 6 is about basically taking two shapes and putting them together. I guess a trick about this stuff is that you are usually excluding one of the sides. So the reason they kind of put this stuff is to make sure you not necessarily know how to just use the formulas, but you kind of know what each part of the formula is. So using your formula sheet, you kind of need to pick and choose which parts of the formulas you're going to use. So hopefully, Shayna, you have that. Go back here. So a composite object comprises two or more distinct objects. To determine the volume of a composite object, and identify the distinct objects. So you need to figure out what you're working with. Calculate the volume of each object, then add the volumes together. So kind of funny that we would have just completed a question exactly like this, and this is the first one that comes up for this lesson. So we have a composite object here. What are my two objects? So it asked me to find the volume, so I'm going to have the volume of a cylinder, and then I'm going to have to add to it the volume of a hemisphere. I'll just write it as H sphere. This is almost exactly the same problem we just did, so you guys should be experts and I should be too. The volume of a cylinder from our formula sheet is given as the area of the base times the h. And the base is just a circle. So pi r squared times the height. The hemisphere is 4/3 pi r cubed, but we're going to take half of it. So 1/2 times 4/3 pi r cubed. Now, we know the radius and we know the height because those are both given in the problem. Radius 18 centimeters and the height is the 32 centimeters. So you can do it in 2 steps and then add them together at the end, or you can just do it in one big step. Pi is this fella. It's stored in your calculator as 3.1415 ... So we use the Greek letter pi to represent we use it, what is the significance? Pi, what are we going to define it as? I guess it describes the ratio between the radius of a circle and its diameter. So every time you have a circle, as your circle gets bigger, the radius gets bigger, and the circumference is also going to get bigger. So the relationship between how big your radius is from the middle to the edge and how long the distance traveled around the circle is pi. So I mean, that's kind of the significance of it. Anytime we're dealing with a circle or a sphere, pi is almost always involved because it tells us the relationship between the radius and the circumference. Hopefully that's clear. Kind of put me on the spot there, Devin. Hopefully that makes sense. There's lots and lots of stuff on pi on the internet. So if you want to learn more about pi, you can go out there. There's all sorts of approximations and proofs and all sorts of things. If you're into math, it's endless, really. So pi times the radius, in this case, is 18 squared, and the height is 32. And then I'm going to have 1/2 times 4/3 pi, and the radius again is 18 cubed this time. There's lots of brackets and things in there. Again, it's just order of operations, so just kind of be confident in what you're doing and maybe write down some steps along the way. I'm going to do these in 2 separate steps. I'll figure out the first part, and then I'll figure out the second part, and then I'll add them together. So I don't know what 18 squared is. I'm going to plug it into my calculator. And this is where it's really important that you know how to use your calculator, because everyone's calculator works a little bit differently, and it's difficult for me to tell you how it works, so you need to figure it out by doing these problems with me and making sure you're getting the right answers as I go along. So this first part is 32,572. I'll keep 2 decimal places. It asks for the nearest tenth, so I'll keep 2, I'll go to the hundredths. 18 cubed times pi. Oops. And some calculators won't like it if you plug all of these things in at once and just hope for it to come out right. And some calculators won't care. It just depends on your calculator. So for the second part, I get 12,214.51. I'm going to add those together. And get a grand total of 44,786, and it asks for the nearest tenth. So I get 0.5, and in this case, I'm dealing with centimeters, and I found a volume, so it's cubed. How do you put a fraction in a calculator? That's a really good question. It depends on your calculator. So, like I have my big fancy TI-83. Looks like this. I can put fractions in with the division sign. If I put something in brackets, then use division, then I close my bracket, I can do that. But yours probably won't work that way. So what I will suggest to you is not doing the fractions at all in your calculator. But for instance, if we look at this right here, how would I enter that? Well, in my calculator, I do the 18 cubed first. And then once I hit equals, I would then multiply it by pi. Then I'd multiply it by 4. And then I'd hit equals again. And then once I'd got that answer, I'd go divided by, and I have the 2 on the bottom. And then I'd hit equals again. And then I'd divide it by 3. And then I'd hit equals. And I'd end up with the answer. So that's just kind of one way to do it. And again, it's just you being used to your calculator. You need to know how your calculator works. If you want to break down each step and show all your work, if you wanted to do like the 18 cubed and then put that number in and then copy everything down and then do the pi times 18 cubed and then that would work. Alex has a really good question. Both Alex and Taylor have asked good questions. So the first one is, can you just do 1.333 instead of 4 over 3? Sure, if you have a fraction like that, you go 4 divided by 3 in your calculator, whatever the fraction is, it doesn't necessarily need to be 4 over 3, but if you put it in and you get 1.3333, that would be good. Now, one thing that you've put in there that's really important, Alex, is you put 1.333, and that 3 goes on forever. So 4 over 3 is going to be 1.333, and that 3 continues on. Your calculator, in its little calculator brain, is going to store all of those digits. So you need to make sure when you're approximating that, you're putting enough digits in there so your answer isn't going to be off by a 10th or a 100th or even 1 if you keep rounding these things. So it's always good to use exact values like 4 divided by 3, but if it makes more sense to you to put 1.3333 in there, that's fine. Can you just do 3.14 instead of pi? Taylor, I'm going to go with no, because I know on the exam and even on the tests you guys do, 3.14 isn't going to be a good enough approximation for pi. So if you're going to use an approximation for pi, let's see if my calculator throws the digits at me. It's 3.14159. So if I was going to approximate pi by plugging it in, and if you have a scientific calculator, that button exists somewhere. You just need to find it. But for pi, I would go 3.14159. If I was going to approximate it, I would use that instead of 3.14, because 14 isn't going to be enough digits to get the right answer. Can you divide by 3 before you divide by 2? Yes, the order of multiplication and division doesn't matter. So if you wanted to do it out of the order that I just showed, that's fine. That was just how my brain works, and that's just how I choose to do these types of problems. But for you, it's important to establish a way that works really well for you and stick with it. And be consistent with how you're doing it. If you start from like the cubed and work your way back, like I did here, then that's great. If you want to start at the beginning and work forward, kind of go left to right, then do that. But just be consistent with how you're doing these questions, because if you start doing them different ways, you're going to get confused, and nobody wants to be confused. Taylor found pi. Excellent. Sometimes it's a secondary function, so you have to press like shift and then find it. But definitely any scientific calculator will have it on it. Just a matter of finding where it is on the button. Some calculators have a button. My big fancy TI-83 doesn't have a pi button. I have to go shift to get to the pi. And then my other guy here, I have just a little sharp calculator, just a scientific one here. Same deal, pi isn't its own button. I have to go shift, and it's the number 3, which kind of 3.14 makes a little bit of sense. Shift and 3 to get to the pi. So this is sharp. That works different than a Casio, which works different than, you know, whatever brand you have. So they're all a little bit different. That's why it's really important to kind of get to know your calculator. All right, back to this fella here. The next question asks us to determine the surface area of this composite object. So you can see I have a 5 by 5 by 5, so I have a cube, and then I have on top of my cube a square-based pyramid. So if the base here is 5, then I know the base of my pyramid is 5. If this base is 5, I know that base is 5. So it's a square-based pyramid, and it's asking me to find the surface area. One thing to kind of be aware of is this bottom piece in this question. If it's asking you to find the surface area, then it's exposed, so you're going to need to find that. If this question were like, this is a house, and you need to paint the outside of your house, just kind of like the silo question we did, we're not going to paint the bottom of our house. So you kind of need to, you know, think about how many sides you're dealing with. So in order to find the surface area, what am I dealing with? So I need to figure out what composite objects. I have the surface area of a cube, and I have the surface area of a pyramid. So I need to think, how many sides of my cube are exposed? In this case, I have, if I counted, a regular cube has 6 sides, but the bottom of my pyramid is the top of my cube, and that's not exposed. So in this case, I only have 5 sides exposed. And for my pyramid, what's kind of tricky about that is I'm going to take the lateral area, but not the base. Because the base of my pyramid is actually the top of that cube, and none of those are kind of exposed to the outside. So I don't need to include it. So if I think about the surface area is going to be of my cube, what do I have? Well, I have 5 sides, and the area of one side is going to be length times width. But in this case, they're the same thing. So I could just call it 5 times the length squared if I wanted. That would give me my 5 sides. My pyramid, I'm going to have the area of the triangle. How many triangles do I have? I have 4 triangles. And then the area of a triangle is 1/2 base times height. But in this case, I have 4 triangles. And in this case, I have 5 sides exposed. Hopefully that's kind of making sense. This is where these questions get a little tricky. That's it. Just determining what is exposed and what isn't. In this case, I'm going to go with 5. The length of the side is 5, and I happen to have 5, which is just a coincidence. And then my triangle is going to be 4 times 1/2. The base of my triangle is going to be 5, and the height of my triangle is given as 4. And then I have 4 of those. 5 times 5 gives me 25, and I have 5 25s. It's going to be 125 meters squared. 5 times 4 is 20, divided by 2 is 10, times 4 is 40. Add those together, I get 165 meters squared. So considering the questions we've been doing, that's kind of hopefully a little bit more straightforward. Again, just a matter of you stopping to think what's kind of happening in terms of the shapes there. You have that square base pyramid on the top, the bottom isn't exposed, so you don't have to worry about the base of the pyramid. When you're dealing with your cube, you have the front face, we'll call 1. You have this face on this side, it's 2. The back face is 3. This one's 4. And then the bottom is 5. So we have 5 faces there. Even though that bottom kind of looks like it's not exposed, we could rotate that composite object in space and the bottom would become exposed. If it's asking something like a house or a silo or something that's built on the ground, then we would think, do I have to worry about that bottom or not? So that's kind of where we're coming out with these questions. I have one more question and just a few minutes left, so I'm going to try to get through that. Tool shed. Formed by a rectangular prism with a triangular prism as its roof. Determine the surface area of the tool shed to the nearest square foot. Now, there is nothing wrong with, establishing what shapes you have and just finding the area of them. You know how to find the area of a rectangle, you know how to find the area of a triangle, and you're just gonna add them all together. So the first thing we need to deal with maybe is the base here. It's a rectangular prism. This time it's 4 by 6 by 5. So these aren't all the same. So it's not a cube like the last question. So it's a little bit different, but a little bit similar. The top again isn't a pyramid, it's a prism. So instead of meeting at an apex, what we've done is we've kind of taken our triangle and we've stretched it out. We have another triangle, so that's a prism, a triangular prism. So dealing with, let's start with the bottom here, the rectangular prism on the bottom. Find the surface area of that. All right, surface area of rectangular prism. Kind of need to think about what we're dealing with. So maybe I'll write A on this front face, then we have A on the back face. So we have 2 A's.